Everybody. So here's a nice find. This is a vintage BK Precision 820 capacitance meter. So sometime, I think it was last year, I work at a community college and we got a donation of stuff from a guy. I think his dad had a bunch of electronics test equipment and just random electronics stuff, and they were just looking to get rid of it, and they kind of just, well, in a way, kind of dumped it on us. We were able to use some of the things, but there was also a lot of stuff that was, I mean, a lot of random stuff that we aren't really using, and I was going through the boxes and I came across this. So I did test this thing and it actually does work. So what this is used for, it's used to measure capacitors. So it's kind of like a digital multimeter in a way. Now, of course, some handheld digital multimeters, for example, do have a capacitance function, but the range on that is sometimes limited to a very small amount. So you can see, for example, this goes from, of course, 1,000 picofarads up to 1,000 millifarads, which is, I'd say, quite a good range. And of course, I work on power supplies here on occasion, and it's nice to have something here to test capacitors with. Now, of course, this can't test ESR, but at least you could use it to actually check capacitors to see what their capacitance is. So you can see here it has, again, the knob to select the range. It has a 1 amp fuse for the power supply. You have this knob here. This is to zero out the meter. It is kind of basically an old analog meter. And you got this power switch here to switch it on and off. So if you look here at the back of it, there's a look at the back. It's kind of hard to get a reading on this label because it's being shiny. But you can see at the bottom it's copyright 1978. It kind of gives you an idea of how old this is. It may not be for 1978, it could be from the early 1980s. But it's definitely up there in age for sure. So this unit runs on C-cell batteries, or it used to run on C-cell batteries. Just going to open this up here. Now, I'm not going to actually open up the unit in this video. However, I think I did see a YouTube video of somebody opening one of these up to show the inside. So you can see here, normally it would run on 4 C-cell batteries, and it does have a jack here for a power source. And if I remember right from the video I had watched, I think it ran on half wave AC. You could probably run on DC, but actually what I'm going to end up doing, and this is actually the kind of the way I test it, is I'm just going to run off of 5 volts. So now, of course, with alkaline C batteries, of course, the nominal voltage being 1.5 volts a piece, that's generally at full charge, 1.5 volts. This would run on 6 volts. However, I did test it on 5 volts, and 5 volts it ran just fine. So when I set up this computer room early last year, I installed a power supply and have 5 volts, 12 volts, and 3.3 volts available. And at this desk here, I have 5 volts and 12 volts available. So what I'm going to do is I'm going to actually solder in this power lead. What it is, I took an old plug-in transformer and just chopped off the cord. And I had stripped the ends. So this here is a metal plug, and I have a female jack attached to my 5 volt supply, so I can just kind of plug this right in. It is kind of backwards from how this kind of plug normally works. Normally this is hooked to your power source, and this gets plugged into the jack on said device. So we're kind of doing it backwards, but hey, it still works just fine. So what we have to do is locate the metal tabs that are actually connected to this, and they are on this side. So what I'm going to do is I'm going to solder these wires directly onto these tabs here. And I've already checked and made sure that when I wire this a certain way, the polarity will be correct. I did check it with my multimeter just to be sure. So pretty much what I'm going to do is I'm going to put some solder on these tabs and then attach these wires, and that way I can run this on my power source. Okay, so off camera I went ahead and soldered these two wires on here. I want to do it in such a way that should I want to like run this on C batteries in the future, I could take these wires off and clean the solder off and pretty much restore it back to its original state. So got the wires on there, and what I did also is I drilled a small hole in the back of the case for the cable to run through. So let's go ahead and pull the slack out. And close this back up. And what I could do is I could put a little bit of glue there to act as additional strain relief. So let's go ahead and pop the cover back on. Okay, so it's now ready to test. And what I'll do is I'll just lay it down like this, and we'll plug it in and give it a try. So I'll need to go get a few capacitors to test this with. And we're going to turn this on. You can see. So right now there's nothing connected, so it's going to of course pick up a little bit of noise, and we are on its lowest setting. So if I adjust this up to, for example, 1000, you can see it's 1000 microfarad, it's showing 0. So let me go get some caps real quick to try this out with. Okay, so for this test we have two unused caps. We'll start out with this 3300 microfarad cap. So we may have to, of course, bump this up a little bit. We shall see. Now, of course, keep in mind electrolytic capacitors are polarized. What's nice is you can either use like multimeter leads, like clip leads that have a banana connector that plug into these terminals, or you can make use of the built-in terminals on this unit. And you can see we are getting 3.4 millifarads. So, I mean, that's a capacitor's good. Alright, now we're going to go a little bit smaller. We got a 22 microfarad capacitor here. Same as before, it's polarized, so I'm just going to stick it in. And you can see we're getting 0.024, which that translates to 24 microfarads. So hey, I mean, I think it's pretty cool. This thing still works perfectly fine. Now another example, let me go ahead and find some older capacitors that are out of motherboards and stuff like that. Now, I don't know if I have enough leads on here to work with, but we shall give it a try. If not, I might have some power supply caps. So again, make sure we observe the polarity. This capacitor is marked as 1500 microfarads. And you can see we're pretty close to that. 1.48. millifarads, which translates to you can treat that decimal as a comma, 1,484 or 85 microfarads. Pretty neat. So it's definitely a nice addition to my workbench here. Okay, so I got a couple of small capacitors here. This is a ceramic disc capacitor here, 0.01 microfarad. Now this capacitor and this capacitor are not polarized like the electrolytic. You can just insert it. And when you get the dashes, it's either it's still trying to read or you got to adjust your knob here. So looks to be 10.3 nanofarads. This one here reads at about 35.5 nanofarads and it's marked 0.033. So again, if we look at the back of this, it does have conversions. So for example, 10 nanofarads is the equivalent of 0.01 microfarads. So it's definitely nice to have that conversion chart on the back as a reference. So yeah, again, pretty cool. Now the switch on this is a little iffy. Might need to open this up at some point and try to clean that out. You see how it's kind of touchy? But other than that, I mean, 1970s or early 1980s technology still working. As far as I'm concerned, I don't think it's ever been serviced or anything. It's most likely in original condition, aside from the mod I just did to it. So yeah, pretty cool. This is definitely useful at my desk here. Again, this was kind of the equivalent of one man's junk. They didn't want it anymore, so they just gave it to us, and of course we didn't really have a need for this in the lab because we got meters already that measure capacitance, at least for our needs. So yeah, pretty neat. So that's a look at this old BK Precision 820 capacitance meter. Hope you enjoyed this video. Thanks for watching. Hey everybody. Thanks for taking the time to watch this video from Fluke channel. If this is your first time, please subscribe to the channel and be sure to tick the bell so we get notified of new video posts. Please like this video if you enjoyed it, leave a comment, and share this video as well as the channel with your friends and get the word out. Also, I have a second channel, that's CubeCompMTDX. Over there you'll find videos about thunderstorms and weather, cycling, and videos about me personally. Feel free to subscribe over there as well if you like. Again, I really hope you enjoyed this video, and thank you so much for your support.